Okay. Happy Thursday. Feels like the day after Friday, like yesterday should have been Friday, but here we are and it's Thursday.
On the fourth day.
So we have an exam next week. We got out the next homework and our first programming project. I am making that due before the last week, like I have historically. This project has historically been due when the other project is due in the last week. And my experience is 80% of people wait until the last week to do them anyway. So it just does not do anyone any services to release it early and then make it due later. So it's going to be due a little bit earlier than that. Yeah, not too much more to say than that. I try to give people options when I can, but when I see people stressing out at me at the end of the quarter about that, just have to do something about it. So, yeah, exam week from tomorrow. Project, homework due next Wednesday, but if you get it in by Monday, then I can guarantee that you get it back before the exam. Otherwise, TA will work very rigorously to try to get as much return to people as possible. Is there any other, if there's anything else? This class is so easy to have announcements for because it's so nicely structured. It's so weird to teach this and software engineering in the same quarter because this class has nice streamlined announcements. And that class is just a jumble of, there are 10 things going on right now that you need to keep track of.
Yeah, make sure the peer reviews are in today. You have the design meeting tomorrow, get the test on Thursday.
Yeah, exactly. It's all over the place. All over the place.
You've tested it? You were tested it?
Quiz, small quiz.
It's right here.
Oh, fine.
Future. Yeah,
Some.
we only have one person remotely too.
Noah.
It is not.
Oh.
He decided to say no to class. If you're watching this back, Noah, I'm so sorry.
That I realized someone was gonna.
Poor Noah. Sketching straight.
All right, so last time we went over our first example of the context-free pumping lemma. We found that, so to recap, there are 5 things in the context-free pumping lemma. There was U and Z that are getting you to the recursion. There was V and Y that's getting us through the recursion, and then X that's getting us from the termination of the recursion to the termination of the string. So we find that when we do this, we end up with quite a few different cases. And in this just string A to the N language, A to the N, B to the N, C to the N, we picked A to the M, B to the M, C to the M, and there ended up still being 5 cases. We could combine quite a few of those cases into 2 larger logical lumps, classes. And we looked at what it would look like to do well or less well in terms of how much work it would take to go through and prove those different cases. So this was our first example. Were there any questions on this? Any further recap? I think I have 4 examples to go through of the context-free pumping lemma, but anything that is this example specific before we move on to practice on the next one?
Why do we need VXY to be greater than M?
Because it's the same reason that XY was larger than M last time.
Yeah,
It was less than or equal to M. Yeah, the VXY should be,
the length of the loop.
did that say less than or equal to M? I think it should say less than or equal to M. Oh, yeah. So it says you need it to be greater than M, which is not allowed. So you can't pick A's, B's, and C's. You can't spread across the A's, B's, and C's, because in order to do that, there are MBs.
Right.
So you have to add AC and NA on either side of that. So you would need, in order for V and Y to contain A's and C's, the length of VXY would have to be larger than that, which we can't allow. Good for a second example? Away we go. Show that the language, a string followed by exactly that same string, is not context free. I think I may have spoiled this in office hours to a person or two who might have been there at some point. But a good string to pick for this, because I think you also tried to show this as being not regular at one point. It turns out it's also not context free. Maybe start with some intuition. Why can't we use a stack to figure out whether we have a string followed by that same string repeated?
Because the stack shows you what the reverse of W is.
Yeah, the stack would be doing that. This would work wonderfully if we had access to a queue rather than a stack.
Is that foreshadowing or?
It turns out to not remotely be interesting.
Oh,
There's no class of language that carrying a queue with us could recognize that has any real use that carrying a stack with us couldn't. There's nothing new and interesting we can do with that. So we don't really study it.
Like it's a substack?
It's slightly different. It's a slightly different class of languages. So instead of being able to represent WWR, we can represent WW. Does that lead to, you know, some unlocking of some new feature in a compiler that allows us to be able to parse things faster? Or, and the answer is just no, not that we found so far. Morgan.
X and Y can be the empty string, right? So,
In this case, B and Y in this case,
yes,
X,
so X can't be empty again. B and Y can be empty.
X and or Z can be empty, but either V or Y at the very least has to contain at least one character. Concatenation of VY.
Yeah, so what, I'm saying, like, just B. Like the single character cannot be.
It could be the recursion. Yeah, you could. B would have to belong to either V or Y. And one of them would be empty, but that is allowed. What have we chosen for a string? Has anyone found something that they think is going to work?
intuitively, the only thing I can think of is like A to the M, B to the M, A to the M, B to the M, because it's probably gonna be just big enough where you can use it for anything. But, okay.
That's exactly what happened.
Like 9 times out of 10, you put something to the M, then you can figure it out from there.
Yeah.
Like,
In case you're stuck at the cases step, here are our cases. Does it make sense why these are the cases? That everything that is a possibility of a window of size M across the string. So a window of size M can hit just A's, hit A's and B's, just B's, B's and A's, and that's it. What's the logic? Where do we go from here, and what is the I that works in each of these cases?
And I equals to 2 for all of them, we're integrate them in.
Yep. I write down, it really is any I that will work. I picked I equals 0 just to be able to show it, but really any I that's not 1 will work. If we add some A's at the very beginning to the first A to the N, B to the M, what we can attach ourselves to is the first set of A's and the second set of A's. They need to have the same number of characters. So if BY is in just the first set of A's, you're going to be adding or removing at least one A from that first set and not to that third set. Second set of A's, the third set of characters. If we have some A's and B's, then we're going to be adding at least one A and or at least one B to this first A to the N, B to the M, which is going to, when we look at the structure of these A's and B's compared to these A's and B's, that's going to be of. If we see all B's and we compare B's to B's, these have to be the same number of B's because they're both M. And that becomes not the case. We don't get the same string here that we get here. That breaks. And if we have B's and A's, that's a little bit harder to see. But if we're pumping B's and A's here, we're comparing these B's to these B's and these A's to these A's. And it's no longer WW in that case. So you have to tie it back to the string being repeated. If we insert anything at any point here or here, it breaks that same thing is repeated. If we have a combination, that combination is not repeated. And if we put something in the middle here, then the middle point here, these A's don't map to these A's, or these B's don't map to these B's. In the WW pattern. So that's the intuitive approach that I like to use for you to write out that no matter what case player 1 picks, you can pick an I, 0 or 2 will also work. That leads to this not representing the WW language. And that's basically what I just said. How are we doing?
Pretty good. So for the decomposition of X, Y, Z, Y could be up to the B's or A's in the middle. Is that possible? If there's only M states in the DFA, doesn't Y have to be?
That's if this is a regular pumping lemma. This is a context-free pumping lemma, which means that VXY can be up to length M across the entire string.
Oh, okay.
Yeah, we can't dock that at the beginning of the string like we could in the regular pumping lemma. Now we have to release that constraint, and we're looking at all possibilities of a sliding window of size M across the string.
Good. I thought this was homework review, so I was like, wait, that was not what I did that. I was like, am I just totally?
This is one of the weirdest parts of this class, when students are doing homework on the first pumping lemma, and that's what they've been dreaming and you're having nightmares about right before coming to class, and they come to class, and that's just more pumping lemma, but it's the other pumping lemma.
It's the pumping lemma.
Is anyone actually having pumping lemma related nightmares yet?
Not yet. Not yet. After last night.
Last night,
That's the best.
I was dreaming that I was still doing my homework from yesterday, that was the pumping lemon.
Yeah.
I was up till 11 doing it. Yeah. I could have stayed up later, but I'm so fried that I just.
So here's a visual. Note that VXY has to be less than or equal to M characters, so we're just looking at all possible breakdowns where we kind of shift this. We have really three axes of control. We have the size of VXY, which has to stay less than or equal to M characters as we slide that around. And then we can slide how much of V and Y, how they are sized within that. So we could make V and Y almost disappear and consist of just a single character, or make X completely disappear and VY would be the entirety of those M characters. And then as we slide that around, we see that we have less of a U or more of a U, less of a Z or more of a Z as we create this string.
X being empty would be the equivalent of like terminating on lambda.
Yeah, you go from the recursion, and once you're done with the recursion, there's the string. There's no non-terminal to evaluate to create the rest of the string. Thoughts or questions on visualizing how this works within this example?
AB to the M work, like AB to the M, AB to the M work as a, like repeating ABs.
Probably, I think it would, because what you want to avoid is having A's and B's and A's in the same. And there's no sliding window that would allow for multiple sets of A's or multiple sets of B's. That would make your life harder. Yeah.
Are you gonna make this PowerPoint file available to download?
Yes. Yeah, I want to do that sooner rather than later. What I hesitate to do is reveal it before the class where we go over the examples, because then if you're reviewing it before class, then you see all the examples and don't necessarily get the experience of solving it for the first time and then comparing what is it like when I solve it versus when we go over it. That to me helps people understand what don't I intuitively get and need to study with regards to those problems before you start working on the homework problems, before you see them on the exam. Is why I try not to do it before class, but if that's useful to people, then I think reconsider. Yes, it absolutely should be up. If at the time you're looking to review it, it is not up, or you think you want to do that day, and it's not up, please send me an email and I will make sure to prioritize that. Yeah, you should not be taking notes necessarily on exactly what's on the slide, because the slides will be available. It's more important, I think, what I say and what we discuss and how that ties to the material that's on the slide. That to me is the single most important thing you can write down. Or something that you got wrong and you want to say, this is what I did, and I know that this is what I should have done. I make this kind of mistake. That's also really good to have notes of. We ready for a third example? Does the second example make sense? All right. How about a to the n factorial? So as always, what's a good choice for the string? Not really much of an option. You could take a to the m over 2 factorial. Is that guaranteed to be a string that's longer than m? For small values of m, not necessarily. A to the m factorial guarantees that it must be. You could say a to the 2m factorial, a to the m squared factorial, a to the m factorial, a to the m factorial factorial. Is there any value to any of that?
No.
No, a to the m factorial will be good enough. Don't overcomplicate it.
About a to the m such that m is the factorial of some n. That'll probably be too hard because you gotta work backwards to figure out.
This is kind of similar to the homework question, was it? K to the 2. Cause you can never scale like enough long term. Or it's too small and you scale too fast.
This becomes a little bit more challenging, but I also want to introduce some of the math tricks that you need to be aware of when you solve some of these problems. So we've seen one of them on the homework that was due last night. One of them involved utilizing a factorial to solve the not equal problem.
Yes, yeah, I don't know what he's talking about.
Was that the one, was that the one where it's like show that, the one where it's not supposed to ever produce prime length strings? That one?
No, it was just it was the a to the n, b to the l, I think, where, and then I guess it was a to the k, such that n is not equal to l, n is equal to l and n is not equal to k, or something along those lines. So when I go over as an example, it's just a to the n, b to the l, where n is not equal to l, because it's very similar. If you want to see that kind of proof, feel free to swing by my office hours and happy to talk. It's kind of involved, but once you understand it or you see it, it makes a lot of sense.
So basically, you're just saying that the recursion part must be equal to some number. And then so you're saying that,
So yeah, we have to loop back into another factorial.
yeah,
I feel like I did the opposite of this where it says when you go to the next factorial. you're shy, but if you go back, you're too much.
That would work too, I think. So I proceed to find the contradiction like this. So we can now attempt to take out k plus L from m factorial. And that has to be larger than m minus one factorial because the difference between m minus one factorial and m factorial is a scalar that is less than that m. There's no k plus L that will get you down past m minus one factorial. And this is it. We're done at this point. We found the contradiction, but the contradiction is more mathematical than it is logical. I mean, there's logic in that, but
Right.
It's more of a definition of factorial type of proof rather than exhausting all of the cases.
You know, to say that the minimum size of M,
Yeah, we can't say anything about a minimum size of m.
but the minimum size of the loop has to be one to cover all factorials.
Yes.
right? So you can just say like. N factorial plus one is not any factorial.
You could go with plus k plus L and try to reach m plus one factorial and see that you couldn't possibly do that. There's no way to pump that. It's just that if you do that, there's nothing that says that a scalar of k plus L can't hit a particular factorial. So it does make more sense to pump down than up in this case and try to hit m minus one factorial. Because we know that we can't hit that and we can't scale it. We can't go I equals 3, I equals 4, I equals 5. We can only set I equals 0, which means that we're taking out one k plus L. And we know we can't hit m minus 1 factorial. If you set I equal to 2 or 3 or 4, we don't know if some scalar to that hits a factorial. That's why. So this is the kind of problem that I might throw at you on a homework, but I certainly would not throw at you on an exam. This requires a little bit too much real-time knowledge and application for me to want to put that on an exam. I would feel bad about that. I would feel like at least half the class would take the entire period to be able to put together their best effort on this, and I want to test more than one thing.
Yeah, I mean, like, totally, I feel like this is helpful if you try to be like, okay, I haven't thought about factorials in a while, let's go over some factorial rules.
Right. Right. It's much better review when you have access to the internet than it is, and learning when you have access to that than it is. Do you know how to do the pumping lemma? Let's throw something at you that requires that you know the pumping lemma and you know factorial rules and you know mathematical manipulation and you see the logic associated with. Whenever I find too many ands in those questions, I either need to split it up into a multi-parter or I need to find a better problem, come up with a better problem that actually tests what I'm trying to test.
I mean, I do have a question about this one.
Yeah.
So if our factorial was 24, if that was m factorial, and
Yeah.
we're trying to pump down to reach 6, right?
So 24 factorials, we need to pump down to get to 23 factorial.
No, I mean 4 factorial, which is 24,
Okay, yeah,
right?
okay, yeah.
So 4 factorial to get to 3 factorial, so that's the difference of 24 and 6. So couldn't we decompose it such that K and L could each one removes about 9 A's, so that removes about our 18.
Remember that Bxy has to be less than or equal to m, which is 4.
Okay, there, okay. Thank you, that makes total sense.
Yeah.
Okay, m was 4, not m factorial.
Correct.
M was 4.
And there's no way that reducing something by a sum that is 4 or fewer can possibly get you from 24 down to 6.
is mathematically impossible. Okay. Yeah, that cleared things up. I was like,
It's always good to have that critical mind. If something like that does not work, make me explain it so that it does work, please.
Right. Well, I probably wouldn't have had to ask for explanation if I just had more copies.
That's
fine.
It's okay, I probably would have been like, huh, if I'd had less. All right, last example. This one will probably be the most mathematically involved. Let's see if we can find an answer to this. A to the n, b to the j, such that n equals j squared.
We assume that n is greater than or equal to 0. Which is
This does not make that assumption, so we should be able to have 0 and 0. So are there more A's or more B's in this string aside from the 0 case?
There'd be more A's.
Yes, that is the important thing to see from the people very frequently mix that up. So if you see anything like this with an equality in there, just make sure that you start with even an intuitive statement like, are there more A's or B's than this in the general case? That will put you on the right track. Hint toward a future exam question that I might ask. I have one in my box that frequently gets mixed up.
I have a feeling making J equal to N would be the way to proceed.
I could, but I'm gonna try.
Smart, I like that, run with it. Exactly what I have. Yeah,
I like how big lemon can be this thing where like. You think that deciding W is like super complex and then also then you try to do something really cool and fancy and then all of a sudden you just realize slap that on there. Other ones doing.
yeah, there are some times where it feels like M was surgically chosen out of a bunch of possibilities and that's what unlocks it, but more frequently than not, there's a good choice that is readily apparent, or that it's not more complicated than, do I just substitute N for M?
I have no idea. Start writing it down.
This one's a real challenge. This one would probably be the challenge problem on a homework, if I even included it in a homework. I felt like going over something a little bit more complicated here, because sometimes in this course, I go over the base case and then I send you off to do the more complicated homework questions. I wanted to have a complicated one or two in class.
Not 2 minutes squared. So.
Yeah, we need some way of saying if B is all A's and Y is all B's, is there a way to make the B add enough A's and the Y add few enough B's that the difference becomes the next M squared, M plus 1 squared, and M plus 1? Is that possible? If so, we're screwed. If not, there's some algebraic method of showing that. So every other case here is fairly straightforward, similar to other stuff that we have seen. If By is all A's, pump up or down, and then we're not going to have the square of the number of B's anymore. If it's all B's, adding some, removing some changes M, or what would have been M, and we're not changing the A's, so M squared is not M plus or minus the length of By. If there's overlap in A's and B's, but there's overlap of B on the A's and B's, and Y is all B's, or Y is A's and B's, and B is all A's, then it's also easy to show. Because as you pump that more times, it won't work. You pump it down and it won't work. But we need some way to show if B is all A's and Y is all B's, that it's still impossible. And a little bit more involved, on the more involved side. We can break this down a little bit further and make them non-empty. If they are empty, it's trivial again. If B and or Y is empty, it just reduces to those cases where By is all A's, By is all B's. But if we make the assumption that B is not empty, Y is not empty, how do we proceed? Do we have that level of algebraic intuition? Utilize this possibly? Expand. Pair. This finishes it off.
I had M squared plus B and then plus Y. I don't know, right?
Yeah, that's absolutely on the right path. So we know the length of y has to be greater than or equal to 1 because of the assumptions that we're making. They're not empty, otherwise we'd be in other cases. So we can compare that and say that that's going to be at least, but possibly less than m minus 1 squared, which we expand. When we expand it, we can take the 2m plus 1 and state that that is certainly less than the length of v. For any possible v that it could be, because remember that v is involving the, it's also non-empty. So now we have another way of showing that there's no way that that can reach the next square. Or the previous square. So here's an algebraic example. Any questions on that?
What if Y is 1?
That's,
Then it's equal, not less than or equal. So the equality still stands and
since V has to be larger than 2m plus 1, or it is assumed to be.
I see people staring, which means there's still crunching going on, which is good. But also that we haven't gotten there yet.
How does minus 2m plus 1 be replaced with V?
It doesn't necessarily get replaced, we just know that that has to be less than the length of v. Because when we combine v and y together, we know that v is made up of, in order to be able to get to the next square, so m squared, we start with m squared, we have to get to m plus 1 or m minus 1 squared. So the length of v has to make up the difference of that. So v has to be at least 2m plus 1 in order to get to that, and v cannot be that long. Due to that constraint. The length of vxy has to be less than or equal to m. That makes sense.
It's less than that, or has to be less than that.
Yeah.
So when you swap it out, it goes up.
Yeah.
It has to go up less than.
Yeah.
My intuition for this case was to set up an equation to solve for like m squared plus x is equal to m plus y. Like there, and then solves to show that m can't be any single integer.
I think that might work.
I'll show you.
Yeah, I'm curious to see that. As usual, there's not one way to do this. This isn't the one correct way. There are algebraic manipulations that will allow you to show any approach to this. This is just one such approach. But this is the hard question. These are the hard questions. The basic ones that you would see on an exam are more like examples 1 and 2, and less like examples 3 and 4. Examples 3 and 4 are more preparing you to think along the lines of homework. Examples 1 and 2 are helping you to think more along the lines of just, can you show that you understand the basic bit on an exam? I could see something slightly harder than examples 1 or 2 being on an exam, but only slightly. Now that we're kind of through 4 examples of this, I'm curious if people feel like it was harder to learn the regular pumping lemma or the context-free pumping lemma after having learned the regular pumping lemma.
I think it's harder for me to wrap my mind around this than the traditional pumping lemma. Because it feels like there's a lot more like guardrails and constraints where it's just less to think about. And so it feels a lot more straightforward. And even though this is just building on that idea, at least for me, there feels like there's a lot more steps in logic I have to go through and think about.
That is certainly true in the actual proofs themselves. These proofs are harder to write.
Oh, the concept makes sense either way. It's just like, I find these substantially harder for me to feel comfortable with compared to the previous ones.
Good to know.
Yeah.
Yeah. Yeah.
The first 2 examples were like, I guess I was here for the second example, or the second example is like, just seems to me like it's, you just have to consider, it's like regular level, but you have to, the thing that you have to consider is the cases that previously were regulated by the fact that M was only to the front, and that just seems like, you know, the same thing times 3 a little bit, you know?
Yeah.
It's not like necessarily harder to learn. I mean, I'm sure this stuff makes less sense, it's like more difficult.
Yeah, I think if I'd gone over questions that were this difficult when I introduced the regular pumping lemma, you probably would have felt that way at the end of those examples as well. So it probably would make more sense for me to ask you this question after you had a chance to do homework on it.
It was kind of
We're
nice
at the
because
same page.
I watched a I watched a YouTube video where somebody was trying to explain something and went through all the cases that weren't regulated by the fact that M needs to be the first 3 characters. In almost exactly the same one that was. And it was, and he just like chopped off the last 2, like, yeah, this doesn't work because these ones are, but it was just the same work, it was just more work, you know?
Yeah. It is the same idea. It's just a couple of constraints are removed, which makes it a lot harder.
There's no plan where I come up with something. Not right now, at least.
Yeah, it's a big challenge. But I wanted to give people some kind of reference when there are some more challenging homework problems to come back. This looks kind of similar to, and come back to this, use this as a guide and use that to solve. But let's meet back tomorrow and we'll go over a little bit of pumping lemma stuff. And then we'll never touch it again. Aside from, your homework and your exams. So it'll come back, but not lecture anymore. Ooh, my job here is done. Goodbye, runs away.
Until office hours.
Right.
You could only
Yes.
run away for so long.
You assigned this, you get to torture through it, that help me understand it.
You're gonna slam the doors, it's gonna be like one of those boots with the owl on it, like in the comments. So your office hours are.
Yeah.
Okay, I'll show you my thing.
Yeah.